Okay, here we go. Classwork time. So, I'm asking you in the reading to pay really close attention to the ratio between the parts of a bicycle that they talk about to do calculations. Let's take a look at that right now. So, when we're calculating IMA, it's a ratio, right? Dividing one thing by another, a ratio of forces for mechanical advantage and a ratio of distances moved by those forces for the ideal mechanical advantage. And so these are things that we can measure, especially the distance or the displacement, part. It's really easy to measure. When we're talking about a wheel and an axle, whether it's a wheel like this and the axle being the shaft or the pivot point there in the middle, or when we're talking about a bicycle like this, where we've got whoops, the wheel and the axle, right? Those things are connected. There's a ratio between their sizes, and therefore there's a similar ratio between how far they revolve in every rotation, and we can use that to solve problems. So let's go to the next page. Some things you should have got out of this reading here is that the forces are the same no matter where you are on this chain. How many chains are there? Think about it for a sec. How many chains on this one bike? Just one, right? So the force is the same all the way around. And so what's different is, well, what is different? What's different between these two gear sets, the front and the rear? Maybe you said size, maybe radius. Can you count the number of teeth? Right? What do I mean by teeth? I mean these individual little teeth right here. All right, those are all teeth. You can count those. And on my son's bike, they're different. Right, the one in the front's bigger, the one in the back is smaller. Um, all bikes are set up this way, and so why? Well, if we've got two different machines, we can multiply or find the product of the mechanical advantages of those two things. And if we wanted to solve for the ideal mechanical advantage, we could compare the radius of the things that are connected. So in the front, we've got the pedal, right? So this has a radius, and we can measure from here to here for that radius. And then we can measure the radius of the gear set, again, from here to there. Now on the back, we've got a similar ratio. We've got from the axle to the edge of the gear set, pretty small distance, and then from the axle to the edge of the wheel, pretty big distance. So that's what all these things are talking about here: pedal radius, front gear radius, rear gear radius, wheel radius. We can measure all those things pretty easily with just a ruler or a tape measure, and then we can figure out the ideal mechanical advantage. We can move these things around a little bit to connect some of the concepts. Like one easy way to figure out ideal mechanical advantage is to compare the number of teeth on the front and rear gear. If you're a biker, then you know about this stuff already because you shift gears, and this is why. You're shifting gears. You're shifting gears to get the ratio of teeth in the front and the back the best for whatever you're trying to do, right? So that's what you should have got out of